Yeah, welcome to today's class. Today we want to look at hexadecimal number system. I told you a number system is a method of representing um, numbers using symbols and rules, right? And I told you that the symbols in itself does not have meaning. So meaning is imposed, not inherent. So hexadecimal number system has to do with what? Base 16. This is what? Base 16. What it's simply saying is that we have 16 digits to play with in creating infinite numbers, right? So what are these symbols? The 16 symbols that we have. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A, B, C, D, E, and F. So 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 digits to play with. Now, how do you count in hexadecimal? So you have up to 16. You're having 0 to 16, right? So which means 0, 1, 2, 3, 4, 5, 7, 8, 9, 10, up to 16. Now, if I'm to count this, that would simply be 0, 1, 2, this hexadecimal. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, if I'm going to count 16, how do I write it using this number? When you look at it, we only have 16 digits. And this 16 digit has represented 15. Now I want to count number 16. How do I represent it? Same thing, placeholder. Because of 0, we have 0 as a placeholder. So we can create that structure. So what do? We are going to move from here, from this place. We are coming up. So 16 will be what? So 16 in decimal, right, will be equivalent to what? 1, 0. So 16 will be 1, 0, meaning this 1 has 16 things inside. That is, the quantity is what? 16. And then you have a placeholder. Without this 0 being a placeholder, this 1 will collapse into this 1. So it means we cannot scale. But because of this 0 being a placeholder, this is going to scale. Now, if you convert this to decimal, how will it be? Since it is base 16, the formula is still the same. Value equals to sum in bracket digit, right, multiplied by base raised per position, right? That is still it. So this is 0, this is 1. So sum digit is what? 1 times base 16 is 16. Hexadecimal is base 16 plus 0. 0 times what? 16. So 0 is what position? 0. This is 1. So this will give us 16 times this will give you 16, 1. That is 16 plus 0 times this one is 0 multiplied by 1, which will give us what? 0. So plus 0. This is what? 16. So 17 in decimal will be what? 1, 1. That is 11. Right? Will be 1, 1. Because if you do the same thing, it will be what? 1 times 16 plus 1 times 16. Then this is position 0, this is position 1. So this is 0, this is 1. This will be what? 16 plus 1 times 1. 0 raised power 16 raised power 0 is what? 1. 1 times 1 is 1. So this will be what? 17. Right? So 18 will be what? 1, 2. 19 will be what? 1, 3. And then 20 will be what? 1, 4. So you can see in hexadecimal, 14 is 20. Whereas 14 in decimal is what? Is 14. And in hexadecimal, 14 is what? E. So you can see the meaning is not in the symbol. The meaning is interpreted based on the base. So if I write 14 on the screen and I ask you what is the meaning, the real answer is nothing. It doesn't mean anything until I tell you the lens you are going to use to look. So if I tell you, look at this symbol through the lens of hexadecimal, that means this is 20. Right? This is 20. It's not 14. It is 20 in decimal, but written as this in hexadecimal. Whereas in hexadecimal, this symbol, if you want to represent in hexadecimal, is what? It is E. So 14 in decimal is what? Is E in hexadecimal. But 14 in hexadecimal is 20 in what? In decimal. So it is very, very important. So that is what I want to show you. Now, why are we using this hexadecimal? Hexadecimal is a shorthand for engineers because if you have to represent this in this 15 in binary, it is actually 1, 1, 1, 1. If you convert it, that is 1 times 2 plus 1 times 2 plus 1 times 2 plus 1 times 2. 1, 1, 1, 1, right? Now, going by the position, this is 0, this is 1, this is 2, this is 3. So 2 times 2 times 2, that is 8, plus 4 plus 2, right? Plus 1. So this plus this will give you 12, plus this plus this will give you 3. So this is what? 15. Right? So this is 1, 1, 1, 1 in binary. But engineers prefer to use the shorthand to just read it because they use it for memory. So this one we just replace will be what? F. So instead of writing this 4, it is F. So if you are using 8-bit, if you are using 8-bit, this is 4-bit, right? So that is 2 raised power 4. 2 raised power 4, that is 16. So you have a number in hexadecimal to replace it, which is what? F. So if we have another 1, 1, 1, 1 again, in binary, if you convert it to decimal, that is 2, 5, 5. If you do the calculation of conversion, it's 255. So in hexadecimal, you just simply write it as what? F, F. That is base 16. So you see it's shorthand. So instead of writing the whole of this length, you just replace it with this. So that is why in computer, memory is actually written in what? Hexadecimal. But the conversion is always done to binary. So that is what I want to show you in this class. Why I've taught you 3 positional number system: binary, hexadecimal, and decimal. So the next class, I'm going to teach you radix. You know, what we have been looking at is what? The whole number of power. We are going to look at the fractional number of power, and that is where this will come in. So don't forget to like, don't forget to subscribe. Till we see in the next class. Bye-bye.